Hey y'all, we are in module 2, topic 1. And we are in lesson 5, activity 5.3, investigating the centroid. So I'm just going to take it back to the beginning real quick. Okay, so this whole lesson is about points of concurrency, and we have covered circumcenter. Don't forget circumcenter. Let me see if I can find it. So, well, I'll put it over here. Circumcenter is the point of concurrency for perpendicular bisectors. All right, we went over incenter in 5.2, so that was 5.1. 5.2, we did incenter, and incenters are for the point of concurrency for angle bisectors. All right, now we are on median. So let's take a look and see what it takes to make a median. All right, so a median of a triangle is a line segment that connects the vertex to the, I meant a centroid. Did I say median? I meant centroid before. Anyway, a median is a line that connects a vertex to the midpoint of the opposite side. So let's do it. We got to find the midpoint of each side. So let's start with that. We know how to do that. It's just perpendicular bisector. Uh-oh, that was not long enough. Immediately she knew. Let me try that again. Okay. There we go. I was like, I don't want to make my arcs too big, but that was just too small. Okay. All right, great. And I'm going to use that to find the midpoint. There we go. And we're going to continue doing that. I think I can use the same. Hold up. Let me not make that same mistake twice. Okay. All right. I think we should be good to go. Extending that same arc and then creating that same size arc from the other endpoint. All right, cool. And we just need this point right here. And then the last side, you can use the same arc if you want to, but I'll just do 2. Uh-oh. I think I hit that and moved it. I did not. Okay, just checking. All right. Ooh, just barely made it. And then I'm going to draw the midpoint. I'm going to just do like a light. Sorry, y'all, my head's in the way. I'm going to do a light segment right there. And then boom. All right, so we got 3 medians and midpoints, excuse me. So if you just go from vertex to midpoint, that's a median. So there's one. So vertex to midpoint. There's one. And there's the last one. And they all come together right there. All right, let's continue. So you can pause the video now and do the rest or try to do it along with me. Oh, child, what was I about to do? Foolishness. Oh, no, that was fine. All right, so I start with my perpendicular bisector construction. I'm gonna connect just a little one, because all we need is the midpoint. I'm gonna do the same thing for the other 2 sides. Is that more than half? I'm gonna go a little bit more. Oh, shoot, that was pretty close. I was cutting it close. If you're using pencil, I think 0.5 lead would be better for stuff like this, because you need such precision. Hold on, is that gonna work? Yeah, it's gonna be tight, but it's gonna work. All right, we got that one. And we got that one. Cutting it close again, but that's all right. Okay, cool. And then the midpoint goes there. Fantastic. Let's go ahead and connect vertex to opposite midpoint. Do it this way. I am not left-handed. And don't laugh at me, y'all. I am not ambidextrous. Okay, that worked out. And then this one. Whew, that was trouble. That was trouble. All right, cool. Got that point of concurrency. Uh-oh, I don't think that was big enough. Nope. Try again. Think I would have learned my lesson. And connect vertex to midpoint to create 3 medians. All right, last one. All right, I'm gonna be a little lazy with this one and just do the same size arc for all 3 sides, for all 3 from all 3 vertices. Good gravy. Okay, all right, cool. That's enough. Oh, that's enough. Oops, not there. There we go. All right, cool. And then we're just gonna connect like we've been doing, vertex to midpoint. I feel like y'all should be noticing a little something about equilateral triangles and their points of concurrency. Well, just saying, if you've been paying any kind of attention, it should be very obvious what's going on with the equilaterals. All right, so there we go. Make a conjecture about the location of the intersection of all 3 medians, inside, outside, yada, yada, yada. All right, cool. Acute, obtuse, right, equilateral are all inside the triangle. A centroid is the point. See if I can use a different blue this time. All right, so the centroid is the point of concurrency for 3 medians. So 3 medians of a triangle. So each of those points is called a centroid. All right, so that is a centroid. Centroid. And consider the 4 triangles and the medians you just constructed. Measure the distance from the centroid to each vertex. Always, sometimes, never. Let's take a look. We're looking for vertex, the distance to each vertex. So I'm just going to try this one first. That distance, okay. And I'm going to compare it to the other 3 vertices. Nope, not the same distance. Let's check obtuse. This one's pretty obvious. That distance is definitely not the same as that distance. So nope, not for obtuse. Let's check for right. Can't see it. That distance is not the same as this distance, so it's no for right. And of course, as always, we're gonna check equilateral, and it works out. All 3 are the same distance for equilateral. So that's a sometimes. So the centroid is sometimes equidistant from each vertex of the triangle. And I'll just put equilateral only. All right, and if we take a look again, we can clearly see that it's not the same distance from the sides either. So the only time it is for equilateral. So part B, basically the same answer. So side. So that was vertex, this is side. And again, equilateral only. The centroid divides each median into 2 line segments. Compare compare the distance from the centroid to the vertex and the distance from the centroid to the midpoint of the opposite side. What is the ratio? Okay, this is gonna be tough. I don't have patty paper. I'm gonna do what I can. Let's see what I got over here. So if we take a look at, I'm gonna have to get creative. The distance from, I'll just use the end of the paper. All right, so the distance from vertex to, you know what, let's go this way. Vertex to centroid is this long, and the distance from centroid to the midpoint, is this long, okay? So look, do you see it? Do you see it? It's half. So the distance between these two is half the distance between these two. And I can easily verify by folding this paper over, and you can see that it matches up. So it is half. And that's always true for medians and centroids. So the ratio is 1 to 2. So the ratio is 1 to 2, or did I go backwards? Vertex to, I'm sorry, 2 to 1, disregard. So from vertex to centroid is double the length from centroid to midpoint, okay? So again, the distance from vertex to midpoint, vertex to centroid is double the length of the centroid to midpoint. And you can easily verify that by looking at all the examples we did. Oh, okay, that's it, cool.